What is the difference between molarity and molality? Well, to learn about molarity and molality, we have to learn about the concentration. What is concentration? Well, concentration is defined as how much solute is dissolved in a given amount of solvent. For example, consider 1 liter water in this object and 1 liter water in this object, and this 1 liter water I dissolve 10 grams sugar to form a solution. While in this 1 liter water, I dissolve 20 grams sugar to form a solution. We know that this solution contains less amount of sugar, while this solution contains more amount of sugar. So we say that this is less concentrated solution and this is more concentrated solution. Now, let me ask you, how can we measure the concentration of a solution? Well, to measure the concentration of a solution, we always use the two terms, molarity and molality. Just remember that molarity and molality is used to measure the concentration of any solution. What is molarity and molality? Molarity refers to the concentration of a solution expressed as the number of moles of solute per liter of solution. It is represented by the formula molarity equals moles of solute over liter of solution. On the other hand, molality focuses on the mass of the solvent rather than the volume of the solution. It is defined as the number of moles of solute per kilogram of solvent, with its formula being molality equals moles of solute over kilogram of solvent. Let us have an example problem for molarity. Number 1. 0.25 moles of sodium chloride in 300 milliliters of solution. What is the molarity of that solution? So, we're given everything that we need. We have the moles of the solute, sodium chloride, dissolved in the solution, and we have the volume of the solution. However, we need to convert it to the units liters. And to convert millimeters to liters, simply divide by 1,000. 1 liter is equal to 1,000 millimeter, so 300 divided by 1,000, the answer is 0.3. Another thing that you can do is move the decimal 3 units to the left. So let's divide this by 0.3 liters and 0.25 divided by 0.3, that's about 0.83. And that's the concentration of the first solution. Number 2. 60 grams of sodium hydroxide in 250 ml of solution. what is the molarity of that solution. Let's convert grams to moles, and we need to find the molar mass of sodium hydroxide. To do that, we need to add up the atomic mass of sodium, oxygen, and hydrogen. So sodium is about 22.99, oxygen is 16, hydrogen is 1.008, so this is 39. But for all practical purposes, let's round it to 40. So we can say that 1 mole of sodium hydroxide has a mass of 40 grams. So now we no longer have the unit grams of sodium hydroxide. Now all we need to do is take the moles and divide it by the liters, but we need to convert 250 millimeters to liters. So if you take 250 and divide it by 1,000, you'll get the volume in liters, which is 0.25 liters. So notice that we have the unit moles on top and liters on the bottom. Whenever you have that, your answer is the concentration in molarity. So it's 60 divided by 40, and then take that result divided by 0.25. So the concentration is 6 molar or 6 moles per liter. Now, let's have some example for molality. 10 grams of sodium hydroxide is dissolved in 500 grams of water. What is the molality of the solution? Let's start with the solute. So we have 10 grams of sodium hydroxide, and let's convert it to moles. So for sodium hydroxide, the molar mass is going to be, it's 23 for Na, 16 for oxygen. For hydrogen, you could use 1.00 or 1. So we have 1 mole of sodium hydroxide for every 40 grams of sodium hydroxide. So we can cross out those units. So right now, we have moles of solute. All we need to do is divide it by the kilograms of solvent. So we have 500 grams of water. We need to convert it to kilograms. To convert from grams to kilograms, simply divide by 1,000 or move the decimal 3 units to the left. So 500 divided by 1,000 is 0.5. So we're going to divide moles of NaOH by 0.5 kilograms of the solvent, which is water. So moles over kilograms, that's going to give us the molality 10 divided by 40, and that's 0.25 moles of NaOH divided by 0.5 kilograms of water gives us a molality of 0.5. So that is the molality of the solution. What are the importance of molarity? Molarity. Number 1. Quantifying concentration. Molarity helps in accurately determining the concentration of a solute in a solution, which is essential for preparing solutions with precise chemical compositions. Number 2. Chemical reactions. Molarity is often used in stoichiometric calculations to determine the amount of reactants and produced in a chemical reactions. Number 3. Laboratory experiments. Molarity is commonly used in laboratory settings for preparing solutions required in experiments, ensuring consistent and reproducible results. What are the importance of molality? Molality. Number 1. Temperature independence. Molality is independent of temperature because it is based on the mass of the solvent, not the volume. This makes it useful for studies involving temperature changes. Number 2. Thermodynamics. Molality is used in thermodynamic calculations where temperature and pressure variations are considered, as it provides a more stable measure of concentration. Number 3. Chemical reactions. In reactions where temperature changes are significant, molality provides a more accurate measure of solute concentration. And that's the end of our lesson for today. I hope you gained some knowledge about molarity and molality.